Students, now let's move on to the module 3, part B section. That is nothing but a design and estimation of power circuit. Okay, we know power circuits can be divided into two main categories. What are those categories? One, we know power circuit for heaters, coolers, refrigerators, air conditioners, other similar loads. Okay, normal house loads. Okay, that is nothing but a one power circuit. Another one, power circuits for motors, generators, AC equipment, machine tools, other special purpose large loads. Okay, these are all the two categories in power circuits. Okay, in power sub-circuit, load is restricted to 3000 watt and two outlet is allowed. Okay, we know as we know earlier problems, the power sub-circuit is restricted to 3000 watts and two socket outlets only. Okay, use of PVC polyvinyl chloride and cross-linked uh, uh, polyethynyl cross-linked polyethynyl cables are used depending upon the size. Flexible conduit uses to connect end of the conduit pipe to motor. For example, wherever flexible conduit means what, we can bend, we can bend the conduit. So that is the limit of flexible conduit. Wherever it is necessary, we need to connect that one. Wherever it is necessary means near from the starter terminal to motor. Terminals. Okay, there is a motor terminal box between starter and motor terminal box. We need to connect flexible conduit in order to get a flexibility. Okay, now let's move on to the next slide. All of you observe here. All of you observe here. Very simple figure is there. Installation of single motor. General block diagram. Here there is a switch. There is a switch, and then there is a conduit between switch and starter. There is a starter. From starter to motor terminal box, they are going to use. They are going to use flexible conduit. This is nothing but a flexible conduit. In between starter and motor terminal box, there is a dotted line, that is nothing but an earth wire, and then this is a motor terminal box, this is a motor. Here the flexible conduit they will going to erect to the earth, and then from earth to motor terminal box they will going to give. Okay, now why they are going to use this diagram means, all of you observe here, in a large workshop or factory, power distribution is affected from a suitable location known as distribution board or switchboard, which normally consists of a set of insulated bus bars. Here they, in the distribution board, there is a bus bar RYB. Okay, each incoming and outgoing circuit controlled by a suitable means automatic circuit breaker. Incoming and outgoing should be controlled by this MCB or fuse switches. Each outgoing circuit may be controlled in a single three-phase load or a group of such. Okay, individually we can control, or three-phase in a group we can control. Okay, in no case looping out on one motor circuit is to done except when the motors are very small capacity. Means if in case the motor rating is low, we can we can make a loop connection from R to RY to Y, B to B, R to RY to Y, B to B. But here the whenever motor ratings are large, we need not to do that looping connection. So in order to avoid the looping connection, we are going to use this type of bus bars through these fuse wires. Okay, now even then same sized cable must be run from the first motor to second and so on. The cable size should be also same. Okay, circuits and sub-circuits to 415 volts motor or loads must be provided with fuse on all poles, on both poles in case of DC supply, or and on all three-phase wires in case of three-phase AC supply. Circuit supply single-phase motor should not be provided with fuse on the neutral. Okay, here they will going to inform each individual phases we need to provide. For each individual phases we should provide fuses or fuse switches for individual motor circuit. Motor starter, this one is a motor starter, this one is motor 1, motor 2, motor 3. If you observe here, this one is RYB supply, three-phase supply from main distribution board, and then is a RYB supply is connected to main fuse switch, from main fuse switch to RYB bus bar chamber, from bus bar chamber connected to motor through fuse switches for individual phases, and then individual motors through starters. Okay, this is how we need to analyze the general block diagram of motors. Okay. Now another one general block diagram is there. You can take any one. Both are same, from energy meter to main switch to ICTP, ironclad triple pole switch with fuse units. Of course, there is a clamp between in order to connect, in order to hold the conduit on the wall. In order to place the conduit on the wall, we need to use clamps, and then motor starter and metal rigid conduit, and then we need to insert this pipe to the earth, and then here they are going to use some saddles with molded they are going to use, and then this is a coupling between earth to this terminal box. They are going to use flexible conduit. Okay, motor earthing. Here also same, everything is remaining same. Okay. Now, all of you observe here important consideration regarding motor installation, wiring, power circuit or heating circuit. All of you observe here this question. Previous slides are not important for your examination. In that slides are very important for your understanding. But here, this question very important for your examination. In case in the module 3 part A, if in case they will going to ask some question from overhead and underground service main. If in case one question from overhead and underground service main, another question from this power circuit. So be careful. This question, especially this question, is very important. All equipment used in power wiring shall be ironclad construction, and wiring shall be of the armored cable and conduit type as per IE rule 51. Okay, of course, here we need to use ironclad construction, means ironclad distribution box, ironclad switches we need to use, and then conduit here, PVC conduits not enough. Here we need to use iron conduits. Okay, woodwork shall not be used for mounting a switch or gear. Here, because of here we are going to use ironclad for a switchboard and all, so that's why wooden work, teak wood is not required here. Looping of conductors and use of giant shall not be done. Okay, as already I inform you, looping is not required here. If in case low rating motor, we can go for looping, but here all the motors are high rating, so that's why we need to avoid the looping of the conductor and joints also. Okay, continuity wires we need to use. In addition to such fuse, all motors should be provided with suitable means for starting and stopping starter in a convenient place. Okay, here we need to place the starter in a convenient place. The starters are used to limit the starting current or disable value. Of course, why we go for starters? In order to minimize the starting current of the induction motor or generator. The length of the flexible conduit used for connections between terminal boxes of motor and starter. Of course, I already informed you the flexible conduit they are going to use between motor and starter. Switches and motor shall not exceed 1.5 meter. 1.5 meter switches and motor shall not be exceed 1.25 meter. What do you mean by this 1.5 meter? I'm going to explain in future problem. Every motor, regardless of its size, shall be provided with switch fuses placed near it. Of course, irrespective of the motor size rating, we need to provide each individual switches for switch fuse or switches for each individual motor. The conduit should preferably be laid in covered trenches to be facilitate operator movement. Of course, conduit we need to covered through trenches. If in case there is a place between, we need to walk between the wall and motor foundation. So in order to provide space for operator, we need to cover the conduit with the help of trenches. Okay, I will explain how to do that one. All of you observe here. Trench means here they will going to use. Okay, pipe will going to use, and here we can walk, so that's why they will going to use these type of trenches, and they will going to cover, okay, with the help of sand, everything. Now, laying of cable must be separate conduit for separate motors. Of course, we need to use separate conduit and separate cable for each individual motor. The minimum cross section of the conductor that can be used for power wiring is 2.5 mm square for aluminum conductor cable, 1.5 mm square for copper conductor cable. PVC or XLP cross-linked polyethylene cable of size lower than 3 bar 0.915 mm copper or 1 bar 1.80 mm aluminum cannot be used for power wiring. Okay. Now, another one point, the current rating of cable for supply to the motor may be based on the normal full load current of the motor, but fuse rating should be based on the starting current. Okay, the conduit used in power wiring shall be electrically continuous throughout and connected to the frame of the motor. The frame of the motor shall be earthed by the owner by two separate and distinct connection of earth. Okay, we need to provide continuity in the conduit and provide earth for every motor. Here, the current rating of the cable for supply to the motor may be based on the normal full load current of the motor, but fuse rating should be based on the starting current. Because why starting current is more? Okay, so that's why we need to select the fuse wire should be greater, should be depending, fuse wire rating should be great, should depending upon the starting current of the motor. Starting current is more. Why? What is the reason? There is a lot of reason. There is one theoretical background is there. Here, that is not required. Here we should know starting current is maximum. In order to avoid the starting current, we are going to go for starters. In order to get a proper fuse, we are proper size wire to fuser ಒಂದು wire ಇರುತ್ತಲ್ವಾ ಅದರ size ನಾವು proper select ಮಾಡಬೇಕು ಅಂದ್ರೆ starting current of the motor we should know. Starting current of the motor, how we will going to get, for example, 16 ampere load is the load current is that 6 times 5 times of the 16 ampere. 16 into 5 times 16 into 5 is equal to what? That is the starting current of the motor. The wire used to earthing conductor, the wire used earthing conductor shall be of copper or GI. While deciding current rating of main switch, controlling a group of motor starting current while deciding current rating of main switch, controlling a group of motor starting current of one motor plus full load current of remaining motor shall be considered. While deciding current rating of the main switch, controlling a group of motor. Okay, here the main switch will going to control group of the motor. So in that time, starting current of one motor, which one is the highest rating, plus full load current of remaining motor shall be considered. For example, starting current of the one motor, highest rating, 10 HP motor, starting current what? Plus full load current of remaining all the motors. For example, 5 motors are there. First motor is 10 HP, remaining motors are 2 HP, 3 HP, 2 HP. Like that, we need to consider starting current of the first motor, 10 HP motor, and then remaining full load current of the remaining motor we need to consider in order to decide the current rating of main switch. Okay, now let's move on to the next point. The main switchboard should be placed very close to the meter board, maximum 150 mm, and meter board should be placed at the entrance as far as possible. Every motor is provided with this switch fuse unit regardless of its size. Meter board and main board starter are placed at the height of 1.5 meter from the floor level. Okay, sufficient light points are provided to achieve better illumination, and then the fuse wire employed for protection of motors should be of such a size that it should carry starting current safely, and care should be taken to see that rating of fuse do not exceed twice of the rating of the cable. Okay, now let's move on to the next slide. Schematic diagram of the motor installation. This diagram is very important for your problem, especially the VTU problem. For this for VTU examination, this schematic diagram is very important. Okay, all of you observe here. Here the first one is meter board. The first one is meter board. And then the first one is meter board. Meter board to main board, they will going to lay the wire 0.3 meters, and then main board to motor switch to 22.5 meter. We need to remember this one for the problem. And then motor switch to motor star delta starter. There is a distance. Motor switch to star delta starter. What is the distance? Motor switch to star delta starter. And then star delta starter, there is a near around 0.5 meters like that. Okay, and then from starter to ground level 1.5 meter, starter to ground level 1.5 meter, ground level to depth of the trench is 0.2 meter, and then from the starter this trench is run 1 meter, and then here from the ground level from the trench to ground level 0.2 meter, and then from here to here they will going to use flexible conduit in order to connect the wire from the ground level to motor terminal box. Here 8 SWG copper wire they are going to use in 12 mm GI pipe they are going to use in order to give the earthing for the motor. Okay, now let's dive into the next slide, that is something by determination of input power. How to calculate input power? There are so many. We have 2 types of power, AC power and DC power. All of you listen here. First one, input power. How to calculate input power? Okay, motors are rated in brake horsepower or British horsepower or brake horsepower. That is power which the motor will be able to supply. The motor power will be greater than motor output. Motor input power will be greater than motor output due to losses. Input will be greater than output. Of course, output is lesser than input. Input in watts, output in watts. So efficiency is nothing but what output divided by input. Here, input power we need to calculate. So that's why input is equal to output divided by efficiency. Rated BHP into 735.5 divided by eta efficiency. Okay, maximum efficiency, since 1 HP metric is equal to 735 point. Here you can take rated metric. Okay, metric HP means metric HP 1 HP is equal to metric 1 HP is equal to 735.5. 1 HP British is equal to 746. 1 kilowatt is equal to 1.341 HP. Here that those things are not required. Just remember, input power is equal to output power divided by motor efficiency. Output power is nothing but what rated BHP into 735.5 is in case 10 HP into 735.5 divided by motor efficiency. Okay, all of you observe here. Next one, input determination of input power. Here, efficiency we should know. Okay, for efficiency, if in case in the problem they will not going to mention, in that time we need to assume. There is a one thumb rule. 1 HP is equal to 50 to 60%. 2 HP is equal to 70 to 75%. 2.5 to 5 HP is equal to 75 to 80%. Large size motor, for example, in 10 HP motor, 90% we need to assume. And next one, determination of input current to the motor. These formulas are very, very important. For a DC supply, what is the formula? P is equal to V into I. P is equal to V into I. In order to calculate the I is equal to P divided by V. P divided by V. Here P is what? P is nothing but a power. Here we need to consider HP into 735.5 divided by V into efficiency. But here DC motors are not required. DC motor calculation is not required. Here just consider single phase motor. Input power is equal to rated BHP into 735.5 divided by eta efficiency into voltage into cos phi. Okay, power factor is a fraction usually between 0.75 to 0.9 depending on the type of the size and size of the motor. Take the one problem. Calculate the input current for a motor of 2 HP single phase AC 240 volts at efficiency 70% and 0.8 power factor. We know the formula. I is equal to HP. What is the HP substitute here? HP 2 into 735.5 divided by efficiency 0.8 as sorry 0.7. V is equal to 240 volts. Efficiency cos phi is equal to power factor is equal to 0.8. Power factor is equal to 0.8. Or substitute everything and get the value 10.95. In order to select the size of the cable, we should know this value, current value we should know. For three-phase motor, IL is equal to rated BHP into 735 divided by root 3 into eta m. Just add here root 3. Okay, root 3 into eta into VL divided VL into cos phi. Take down this problem. Observe here, IL is equal to what is the HP? 10 is equal 10 into 735.5 divided by root 3 into efficiency 0.8. Power factor 0.85 three-phase supplies. So that's why the voltage is 415 is equal to, we are going to get 415 ampere. 15.05 ampere, approximately 16 ampere. So for these values, we need to select the cable. Okay, let's check it out. 10 HP 500 volts input current is equal to 18.4. We already calculate. So for that one, 7 bar 0.915 mm copper conductor we should select. For 2 HP to 240 volt single phase motor input current 10.95, 3 bar 0.915 mm copper conductor we should select. 10 HP 415 volt 3 phase AC motor input current 15.05 as per earlier calculation. 1 bar 2.85 mm aluminum cable or 1 bar 1.80 aluminum cable or 7 bar 0.736 copper cable, 1 bar 1.24 aluminum cable. We can select any one. Between these four, we can select any one. Okay. Now, determination of rating of fuse. Here, there is a complication between motor starting current and full load current. So, all of you understand the fuse wire employed for protection of motor should be such a size it may carry the starting current safely. Because if in case, for example, 10 ampere full load current is there, the starting current is 5 times greater than the full load current. 10 into 5, 50 ampere. If in case I select fuse wire depending upon the based on the full load current full load current 10 ampere. If in case I selected depending upon 10 ampere, the fuse wire will going to blast every time. So that's why it should carry the starting current. It should carry the starting current. So fuse wire rating should be depending upon starting current. So that is the explanation. The fuse wire employed for protection of motor should be of such a size that it may carry the starting current safely, but in no case the rating of fuse should be greater than twice of the rating of the cable. One first case, motor starting current less than normal full load current. In that time, current rating of the fuse based on the motor starting current. If in case motor starting current greater than 2 times of normal full load current, current rating of fuse based on the motor starting current only. Okay. Next one, this is the determination of conduit size. That is not important. Okay. Now, determination of size of the distribution board. Of course, we should know the distribution board the number of ways. Of course, here 3 ways, 4 ways, maximum 4 ways we can use. Voltage rating, okay, so 15 volts. Current rating of distribution board is decided from the number of circuit to be fed from it. Voltage rating of the circuit, starting current of the, of course, current rating, voltage rating, and then number of ways. And the starting current of the sub-circuit having highest current rating. Okay, determination of size of main switch. The current rating of main switch decided by keeping in view the fact that it should be capable of handling starting current of one motor plus full load current of remaining motors to be controlled from it. The main switch ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡಿಂಗ್ ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಕರೆಂಟ್ ಆಫ್ ದಿ ಫಸ್ಟ್ ಮೋಟರ್ ಅಥವಾ ಸ್ಟಾರ್ಟಿಂಗ್ ಕರೆಂಟ್ ಆಫ್ ದಿ ಒನ್ ಮೋಟರ್. ಆ ಒನ್ ಮೋಟರ್ ಯಾವ ತರ ಇರಬೇಕಂದ್ರೆ ಅದು ಹೈಯೆಸ್ಟ್ ರೇಟಿಂಗ್ ಪ್ಲಸ್ ಫುಲ್ ಲೋಡ್ ಕರೆಂಟ್ ಆಫ್ ದಿ ಆಲ್ ದ ರಿಮೈನಿಂಗ್ ಮೋಟರ್ಸ್. ಓಕೆ. Here, this is also very, very important. Determination of type of motor, type of starter. For alwa yav motor ge yav starter na use ಮಾಡಬೇಕು ಅಂತ. Squirrel gauge induction motors ಅಲ್ಲಿ up to 3 HP ಆದ್ರೆ direct online starter, 3 HP to 15 HP ಆದ್ರೆ star delta starter, greater than 15 HP starter ಆದ್ರೆ auto transformer starter we are going to use. Slip ring induction motor ಗೆ rotor rheostat starter, DC series motor ಗೆ 2 point starter, DC shunt motor ಗೆ 3 point starter, DC compound motor ಗೆ 4 point starter. Okay. Now, the selection of earth wire, this is not important for your calculations and all. Thank you so much for listening. Thank you so much. In future slides, let's see, in the future video, let's see, concentrate on 2 problems on these power circuits. Okay, thank you.